Okay, we are going to find the slope of the tangent line for this equation. Since there are both x's and y's, the way to find the derivative of this, which is the slope of the tangent line, is to use implicit differentiation. So if we use implicit differentiation, we want to look at these two terms separately. And since they're two things that are multiplied together, we're going to use the product rule. So the product rule is the first term, which is y cubed, times the derivative of the second term. The derivative of the x is 1, plus the second term, which is x, times the derivative of the first term, which is 3y squared dy dx. We're going to do the same thing for the second term here. This y squared times the derivative of x squared, which is 2x, plus the second term, x squared, times the derivative of the first term, 2y dy dx. And then the derivative of the 6 on the right side is 0. So what we're going to do is we are going to group these two terms together that have the dy dx. And we can factor the dy dx out to the front. So this will be 3xy squared plus 2x squared y. And then these other two terms, we're going to move to the other side. Minus y cubed minus 2xy squared minus y cubed minus 2xy squared. So with this on the left, we now have this equal to minus y cubed minus 2xy squared. To further isolate dy dx, we divide both sides by this. This cancels out, and so this is what we're left with, dy dx. Now, since they give us the point 2, 1, this is x and this is y. We can plug these into this equation we found to find the slope. Minus 1 cubed minus 2 times 1 squared. 3 times 2 times 1 squared. 2 times 2 times 2 squared, times y is 1. So this will be -1 minus 4. This is 6 plus 8. We get -5 over 14 for the slope.